Yowzers, plenty of stuff to talk about when it comes to space weather. And thanks for tuning into the Smash News Network, least busted name of news. We're only bringing you the most detailed imagery of the sun and comprehensive space weather you'll find in the known universe. So lots of stuff to talk about, like geomagnetic storms, which actually continue to rage on here a little bit longer than expected, although they look like they are subsiding. Here is the southeastern limb of the closest star. It's where the new action is located. We've now got 4 likely named sunspot groups down there, and the filament fest continues. You can actually see one ejecting there in the upper left. Huge, huge filaments here beneath the Earth scale and to its northwest. Here's a view of the eastern equatorial region. You can see some plasma ejecting there for sure, as we've got some trans-equatorial plasma filaments no longer hanging out over there. So we've got prominences all around the solar disk. And these solar filaments are the kind of thing that do cause geomagnetic storms. Here's a great example of a filament that is hanging off the edge of the solar disk, which we refer to as a prominence. Great imagery of that. These are all 24-hour videos from the SDO, Solar Dynamics Observatory. And you're seeing the extreme ultraviolet emissions here of very hot ionized helium and very hot ionized iron. 304 angstroms is the ionized helium, 193 angstroms is the ionized iron. There's the North Polar region. As we continue to go around the horn here, there is the Northwest, and I believe the most likely spot to see major solar flares is actually out of this group here as it sets on the limb. And our regular viewers may be aware that flares are much more likely around the limbs than they are on the center portion of the solar disk. All right, so let's get back to some more imagery here. There is the western equatorial region, huge filaments there as well. So likelihood of coronal mass ejections in the earthly vicinity is nearly 100%. Remember, folks, you don't need to see solar flares or sunspots to see coronal mass ejections. These are indeed separate phenomenon. And here is the southwestern limb. And there's a little crown prominence showing up down there. I think it might be the first one for solar cycle 25. How about a little close-up of that? There's a little crown prominence hanging out down there. Also a coronal hole visible to its north. All right, so let's take a look at some full disk imagery here. There is yesterday plus today in SDO intensitygram, and I believe we do now have 4 sunspots down here. So there's one just to the south of this sunspot, one just rose over the southeastern limb, and then there's one to the north of it as well. So I think that we'll have 4 named sunspot groups here in the next 24 to 36 hours. There's your SDO colorized magnetogram yesterday plus today. And let's briefly talk about what's been going on Crescent Earth. Yeah, Crescent Earth. So the first thing we'll do is a volcano rundown. As here at the Smash News Network, least busted name in news, we're not only interested in cosmology, but also what is going on in the backyard of all of you Earthlings out there on planet Earth. Anyway, the volcanoes that are erupting include Semeru, producing a 14,000-foot ash plume over East Java as it explodes. It's a flight level 140. Katmai, now continuing to explode here on the Alaskan Peninsula. 6,000-foot ash plume, flight level 060 over the southern portion of Alaska there, the Alaskan Peninsula. Popocatépetl exploding, flight level 260. It's a 26,000-foot ash plume. Fuego exploding in Guatemala, flight level 150, flight level 210 over Sangay in Ecuador, and flight level 220 over Sabancaya in Peru. Largest quake of the past 24 was quite significant. And there is the, oh, it's not showing up yet on the list. There was a 7.1 magnitude quake in between New Zealand and Tonga. They're in the Kermadec Trench. There is the location of that 7.1 magnitude quake. That came in at 0 dark 41 early this morning. And by the way, if you're not signed up for email alerts at smashomash.com/smashteam, you wouldn't have gotten an email about it. So, it's the perfect time to let you know that smashomash.com/smashteam does send out email alerts. And we sent out a series of alerts about the geomagnetic storm conditions, urging our viewers to go out and check out the aurora. If you want to share auroral imagery with us, hit us up on Twitter or perhaps on Instagram. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/smashteam. The best value is a gold annual paid-up subscription. You'll not only get additional content, you'll have the ability to get yourself an at smashomash.com email address. And email alerts even go out for bronze level. smashomash.com/smashteam. It's our own subscription services site, launched back in 2021 in October because, we needed additional capabilities. So if you want to support the channel that way, you are invited. So we'll go over the rest of the earthquakes here over the past 24 hours. And before that, let's pause for station identification. You've reached the Smash News Network, least busted name in news. So here's the past 24 hours of earthquakes. And let's center our map here over North America. So here are the quakes over a 5 magnitude. Philippines had a 5.2. That was at 16:23 yesterday afternoon. Kermadec Islands here saw a 5.0. So a great example of a foreshock there. So there's a foreshock, a 5.0 magnitude quake preceding the 7.1 magnitude. Also, New York had a 3.6. Shout out to Sherry. Thanks for sending a message about the earthquakes in New York. South Sandwich Islands also had a 5.4. That's been a seismic hotspot for the past year or so. Bonin Islands had a 5.2. It was only about 40 minutes later. And then about 20 minutes after that, there's your 7.1 at the Kermadec Islands. And of course, many aftershocks there, like a 5.4 and a 5.3. Also, we had a 5.6 at the South Sandwich Islands at 2:17 this morning. So that is your earthquake rundown for the past 24 hours. A couple more quakes coming in here more recently, like this 5.0 at the Philippines and this 5.1 at the eastern shores of the Indian Ocean. Let's get back to space. It's where the action has been happening. Exciting stuff. And lots of great information here for you on today's video. So there's the past 24 hours of SDO 171 angstroms, the house favorite wavelength. And by the way, a perfect example of how you can see a highly active state in terms of Earth's geomagnetism and a highly inactive state on the closest star. So at the moment, not a lot of activity there on the sun, but a lot of activity on Earth. A prime example of how, once again, let me reiterate, you don't need solar flares or sunspots even to see major coronal mass ejections. The 10.7 centimeter radial flux now all the way down to 135 solar flux units. So quite low levels there on the radial flux. Another little lull in solar activity. Don't expect it to continue, as we've still got about a year until we reach solar cycle 25 maximum. There's the 1 year graph to put all of that in context. The radial flux is this black line over here. The sunspot number is the red line, and the blue line there, that's the Potsdam AP. That's just an average of global geomagnetism. And the pink line is the 30-day Wolf number, the smoothed sunspot number. Space Weather Enthusiast dashboard here, forecasting a subsiding of this coronal mass ejection impact geomagnetic storm condition. We reached all the way to KP8 twice, which was just about where I forecasted it for. And we'll see exactly what the duration of this was Super important feature here is the magnetic field strength, which we'll get to. Check it out, 29 nanotesla, and it's been even higher than that. Also, we are expecting a coronal hole high-speed stream. Let's see. NOAA's expecting it to arrive as early as tomorrow. I think it'll arrive on Wednesday. Oh, it could be tomorrow. We'll see what happens. So if you missed the aurora, don't worry. There's more to come. Solar Cycle 25's got a long way to go. Let's take a look at Earth's magnetic moment from space. And there is certainly a lot of pressure in the plasma surrounding planet Earth at the moment. So that is depicting magnetohydrodynamic pressure, the units of which are nanopascals. Again, that's the last 4 hours of Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. Again, we are expecting to see this geomagnetic storm condition subside. And let me take a moment to advertise one of our latest pieces of merch. The Croissant Earth Society. When will you stop believing NASA's lies? I mean, people like Neil deGrasse Tyson are out there telling people that planet Earth is shaped like an oblate spheroid. I mean, come on. That's just crazy talk. You got other people claiming the planet's flat or shaped like a pizza. We're here to tell you that, in reality, Earth is shaped like the French breakfast pastry. Croissant Earth. Join the society. And when will you stop believing NASA's lies? Now, of course, this particular piece of merch is designed to make everybody on the internet angry. Hopefully, we enraged you with it. And let's take a look at Earth's magnetic moment from the ground. So these are our ground magnetic perturbations map. This is showing you the likely places to see telluric currents, pipeline, railway, and power grid induction, and indeed the aurora. So that's the past 4 hours of Earth's magnetic moment from the ground. And as you can see, there are a lot of ground magnetic perturbations. Again, we do see this subsiding now. We saw some amazing imagery of aurorae. If you want to share any with me or with the channel, hit us up on Twitter. That's the best choice. Or perhaps on Instagram. So we'll also show the full globe view here. Here's the full planet view. Ground magnetic perturbations for the past 4 hours. Huge magnetic pulses there showing up around the equator, like places like the Indian Ocean, southern India. That is a geomagnetically active situation indeed. In fact, this could be the strongest geomagnetic storm that we've ever covered on the channel. Now, these geomagnetic storms, they do cause power grid induction. And that's what you're seeing here, the U.S. plus Canada here, telling you in millivolts per kilometer the induced current in the power systems. That's one of the many features you can find on the Space Weather Prediction Center. So I looked at poweroutage.us and I didn't see any grid down situations in the U.S. So this is just another prime example, folks, of how there are a lot of alarmists out there that are trying to frighten you about things like KP8 events, saying that they're going to hit harder because of Earth's pole shift and things like that. It's just utter nonsense. And by the way, Western nations have much more fortified power grids than we had just 10 years ago. If you weren't aware, we're happy to inform you of this fact. Probably not bunker requiring. We would have told you yesterday to enter a bunker if it was necessary. So KP index currently still here at 6.67, which is just 1/100th of a KP index point above 666. Anyway, we had 2 3-hour periods here of KP8. And lots of amazing aurora were generated. We'll be sharing a bunch of auroral imagery today, especially on the Twitter feed, perhaps also on the Instagram. KP index currently at 6.67. Geomagnetic storm conditions and decently strong geomagnetic storm conditions. It's just this side of a G3 geomagnetic storm. Again, we saw all the way to a G4 for 2 separate periods overnight. So here's the current 30-minute auroral forecast. Another great feature of the Space Weather Prediction Center. And we had some really lousy luck. I can't understand why I didn't see any aurora here in Pennsylvania. I mean, maybe I captured imagery that I didn't realize. I'll have to go through some of it. But I took a couple of hours of video at 60 frames per second. And I couldn't see jack. I tried taking photos. I couldn't see jack. Anyway, there's your auroral forecast. And let's take a look at the real-time solar wind, as there are definitely some interesting parameters indeed. So I would first note this top pane. All right, this top pane is pretty serious. What is going on with Epic Pen? Epic Pen, what are you doing to me? All right, anyway, this top pane up here, look at these white numbers here. So we have a field of, at this moment before the CME impact occurs, we've got a field of 11 nanotesla with a BZ of -3. When the leading edge of the coronal mass ejection showed up, what happened? The field went up to 27, over doubling in strength. 27 nanotesla was the initial strike with a BZ of -14, a strong negative BZ, which induces lots of currents into Earth's geomagnetic system. So that's basically a pull. It pulls in a bunch of material generating massive currents, and hence the aurora and geomagnetic storm conditions. Now, it did rather quickly subside here. So let's see, about 3 hours later, the field shifted drastically into a positive BZ. So the field strength didn't really drop. It's still, well, there you can see it's 27 nanotesla there with a positive 18. So a much more northerly vertical component of the magnetic field. And then this is when the real fireworks happen. I believe this is when the core was passing, by the way. This is like the leading lip. I think this is the core of the CME, which was much less current inducing and also lower density there in the core. So it was basically like a hollow core. And then the trailing edge actually featured some extremely powerful magnetic fields. There you see a 33 with a -32. So massive vertical component there. The BZ -32 with a 33 nanotesla field. Now, since then it's been subsiding, but we still have very strong fields there. Although they've gone back into the positive territory, so we can expect this to go into geomagnetic unrest conditions here. This is going from a pull to a push, as a positive BZ, a positive vertical component of the magnetic field, is more of a collision with the magnetic field than it is an induction. So 28 nanotesla here, still a very strong field, and a +3 for the BZ. Solar wind density here, 11 protons per cubic centimeter. Solar wind speed here still quite elevated at 555 kilometers per second. That was a great CME impact. Now we saw big variations here in the magnetic field. This is actually an indication that there's a huge amount of plasma. And let me just tweak something here for a minute. Just bear with me here for a quick second. I just want to get rid of something that's in my way. Come on then. All right, here we go. Now when you see this extremely rapid dip in these sudden variations, that is on the daytime side. So here you've got what's happening there is plasma shifting from the daytime side to the nighttime side, from the bow shock side to the magnetotail side and back. And that's causing those huge variations there in the GOES magnetometers. Next, let's take a look at the heliospheric current sheet, as this is pretty uneventful as well. Earth is just in a south pole current sheet, kind of right in the middle there. North pole current sheet on the opposite side of the sun. And let's take a look at our line of sight field plot. Here the solar B field depicted in blue, north solar polar field in green there. Again, you can see on the opposite side, south solar polar field in the earthly zone. So welcome to the South Pole. Earth is right in the center of the south magnetic pole. There you can see that fanned out B field. We'll also show the coronal hole line of sight plot Lots of South Pole-oriented coronal holes and a crazy number of filaments facing the Earth. We'll get to that a little bit later in the video. Of course, we started out showing filaments because those are what indeed caused the geomagnetic storm that is currently continuing. So here is our 211 angstroms wavelength, and you can see very well-defined coronal holes. I'm going to agree with Noah. I think we'll see an impact from this tomorrow. A big density spike followed by an extended and ongoing high-speed coronal hole wind stream. That'll last a couple of days, as that is a very well-defined trans-equatorial coronal hole, the most geo-effective kind of coronal hole, the kind that crosses the solar equator. Let's move to sunspots next. Again, the most likely place to see a large flare, in my opinion, is up here at 3282. (3285) also has some magnetic complexity. We have some groups setting at the limb down here, but I still think the most likely place to see a large flare would be 3282 at the moment. Let's take a look at the SDO continuum plus 131 angstroms. A great wavelength to highlight active regions in the 131 angstroms, and the umbre of sunspots in SDO continuum. Let's drop 131 and zoom in here. So that is a 24-hour video. And again, we are expecting to see 4 named sunspot groups down there in the southeastern limb. There are 2 to the south of this large group and 1 to the north of it last I checked. We'll show you high-res imagery before we move to meteorology here. Let's blast through some more data. We don't want the video to be too lengthy, even though there is indeed plenty to talk about. And thanks to our new viewers, by the way. Congratulations on realizing the channel exists. We had a proton event last night also. Kind of as the geomagnetic storm was striking, we had a proton event. That was kind of weird. Peak flux there was around 1820, and it did indeed cause some polar radio blackouts. The radiation emitted by those relativistic protons, they attenuate the D layer of the ionosphere and cause radio signals to go flying out into space instead of being refracted back down to the planet. Polar radio blackouts there briefly caused. Since then, the proton flux has subsided. It's now going back to its baseline. As far as flaring goes, it's been minor. The largest flare occurred here while we did show prep. In fact, while we streamed the beginning of the show, actually. There was a little C-class intensification. And let's take a look at the past 24 hours here in SDO 94 angstroms. So one of the reasons that we use 94 angstroms and 131 to view solar flares is because, well, they're specifically designed to view solar flares. They take 10 images per minute instead of only 2. Anyway, that's the past 24 hours in one of the better wavelengths to view flares. Keep in mind this is still extreme ultraviolet emissions from ionized iron, 94 angstroms. And let's take a moment to step back here and consider what's going on overhead. So this is the current situation over Lehigh Valley. You've got Mercury trailing the sun there and the sun trailing Saturn. Venus will rise here shortly. In about an hour, Venus will be above the horizon. So if you've got an evening view, you should have a great view of Venus there. Just as the sky begins to get dark. The third brightest object there, my favorite planet, planet Venus. Next, the solar system forecast. So here's where things are now. We'll advance this 1 week. Here's where things will be in 7 days. Mercury and Venus making it a little bit more populated on this side of the solar system. We've got the terrestrial planets on one side and all the gas giants on the other side. Next, we'll look at coronagraphs, as there have been some coronal mass ejections. Are they earthly directed? Well, we don't think so. These are 103 frames from yesterday. There's a CME out of the west. That doesn't look like it's earthly directed. There's another one out of the northwest. That doesn't look earthly directed. Here are today's images. And let's take a look at some more data here. We'll look at stereo A and the Soho Lasco C3. Now keep in mind these are not synced. Please pay attention to the time and date stamps. No new earthly directed CMEs, but there indeed is a coronal hole high-speed stream on the way. We expect it to arrive late in the day tomorrow. You'll see a density spike, followed by a density decrease and a big uptick in the solar wind speed. So keeping you ahead of things here. Here's the past 24 hours in a couple of coronagraphs. Let's zoom in a little bit closer to see if we see any plasma moving around. I suspect those CMEs are somewhat from the far side of the sun here, as we don't really see any plasma motions happening there. Typically, you would see something moving around there in 193 angstroms, which is the middle portion. That's the SDO 193 angstroms wavelength. Those are not earthly directed coronal mass ejections. Now let's talk filaments. Again, there is a massive number of filaments, and we've been naming them after living people. So if you want to do that, you got to join us on Twitter. Just follow the hashtag #NameThatFilament. And there is at least one new one that's just recently formed right over here. Check it out. Big filament there showing up in the eastern limb there, just north of the equator. We've got like 6 or 7 named filaments already on the solar disk. Let's take a look at the latest image here. Major filaments there. This is one of the most highly populated filamentary space weather videos that we've done. Those are not only huge filaments, they're very dense. Like this one here is extremely dense. You can see how dark it is there. That's because it is blocking the hydrogen alpha emissions. So it's probably chemically rich. And that is what you call an absorption feature there. Basically a shadow. And let's continue on to our 131 plus 171 angstroms wavelength. That's another 24-hour video there from SDO. And let's check the last couple of hours here from the GOES 16 SUVI. So we do see some activity over here, some plasma moving around. Besides that, things are pretty calm with a little bit of activity over here as well. So again, the most likely place to see a large flare, in my opinion, is up here in the northwest, followed by this area down in the southwest, followed by this large sunspot. And then there is some possibility of a flare even coming from up here behind the limb in the northeast. And let's get to our bonus features. We don't want the video to be too lengthy. We've got some satellite charging hazards, and wait till you see the ionosphere. It's the most anomalous ionosphere we've ever covered on the channel. So there are your satellite charging hazards, some significant surface charging there caused by low energy electrons on the outside of satellites building up there. Those charging hazards soon to move into the Central Pacific Ocean could cause some minor communications breakdowns. Here's your GOES electron flux here coming up off the floor. Another indication that the coronal mass ejection impact is ending. We'll see that subside throughout the day today. And we're expecting a big increase in the electron flux here coming, followed by another big decrease when the coronal hole high-speed stream arrives. So NOAA's not forecasting an increase in the electron flux. We're expecting it to be up here by tomorrow, and then dip back down when a coronal hole high-speed stream strikes. So we'll have to see what happens there. That is a rough analysis. There is the one-year graph of the relativistic electrons to put all of that in context. We're just coming out of the longest electron drought that we've had in the past year, as you can see with that lengthy trough. Now, the electron flux is measured at the F layer of the ionosphere, and we're going to show that, and wait till you see the low-frequency anomalies. They are off the chart, really. It's a shame we don't have higher resolution. That is the lowest frequency ionosphere that we've covered, at least since around solar minimum. So we've seen some extremely low frequency anomalies. No, that's even, these are much lower than we even saw around solar minimum. Those are absolutely berserk low frequency anomalies there, as the ionosphere puffs up in response to all of that activity. Because keep in mind, this is being measured at about 300 kilometers of altitude. My theory is that this puffs up, actually, and this is why you see such low frequency anomalies. So let me just get the latest image here. Let me let that play through. Here we go. There's today. And here's the anomalygram. And the number of low-frequency anomalies here. This is anomaly in megahertz from a 30-day median. Look at all the red. That is an extremely low-frequency ionosphere. So denser material there welling up and essentially tamping that down as the ionosphere puffs up to higher altitudes, really. So you're seeing that very low frequency there at about 300 kilometers. Low-frequency anomalies are certainly part of today's story. Anyway, there's the latest image. Extremely low frequency there at 11:45 Universal Time. And again, there you can see how low frequency those anomalies indeed are. DAG. We'll also show the total electron content, which is also extremely anomalous at the moment. It depicts the free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with these distances. Here's your total electron content forecast. We've got some areas with electrons really out of place there. So some major GPS errors perhaps happening in unexpected areas, like around midnight local time around the equator. We'll let that play through one more time. And you can expect some oddities with your GPS continuing here as a result of free electrons between your GPS satellite and your handset. We'll close out the space weather section of the video with the latest SDO intensitygram and the latest SDO magnetogram. Again, I think we do have 4 sunspot groups over here now, so let's take a look real quick. Perfect. So we've got all 4. So we've got this group here. That is beta gamma class at the least. And then we've got another beta gamma class. This one might be beta gamma class. And then an alpha class sunspot here. So 4 sunspot groups in the southeastern limb. That is beta gamma class with some tiny little deltas. This one here looks like it is interesting. Looks like we're only seeing North Pole umbra there. Could that be possible? Only North Pole umbra there. So that's a bit odd. Now there might be some tiny South Pole umbra there ahead of that. So that's beta gamma class. This is beta gamma delta class. This group down here is beta gamma class. Tiny little leading umbra there. And then down here, that is an alpha class sunspot group. Anyway, there's your full disk rockback. And let's get to meteorology, starting with nullschool.net's great auroral imagery. So this will show you likely spots to see the aurora. Shout out to our viewers from Munda. If you've got imagery of the aurora australis, again, hit us up. Well, I mean, you can find emails on smashamash.com. There's all kinds of ways to get a hold of us. Drop us an image in the Discord chat. There's a permanent invite link at smashamash.com to that as well. Some major aurora there, likely visible over places like Anchorage. Anyway, let's switch from nullschool.net's auroral view to our standard wind maps. So there are the jet streams of the eastern world. Probably the best overall global weather pattern indicator would be the jet streams. Here are the surface winds, and it's pretty windy around Australia. And also south of Japan there, some strong winds in the western Pacific. Here are the surface winds of the central world. And here are the jet streams. Southern Ocean there looking quite windy at the moment. There are the jet streams. Here are the jet streams of the Americas. Let me move that just so I can show South America and Alaska, as we've got viewers from both locations. So there are the 250 hectopascal winds. We've got a strong jet stream over the eastern U.S. and a divergence, a doubled up jet stream there over the central northern Atlantic. Here are the surface winds of this side of the planet as we blast through the rest of our meteorology segment. We used to make the videos separate, and that led to less views on YouTube. So now they're together. Congratulations. By the way, if you don't follow us on Instagram, you might not see this. We also put up all kinds of other lifestyle stuff, like about training and about diet. So more videos like that coming to YouTube eventually, as there is some expansion of our operations happening here at the Smash News Network, least busted name in news. There is a great image of the moon plus Venus. And thanks for leaving a comment, Mr. Bordages. All right, so here's the cloud and fog situation over the Americas. We use a 3.9 micrometer radiation map there showing infrared radiation to show clouds and fog when it's too dark over half the map to use the visible satellite. You can use it also at nighttime to see the likelihood of your ability to see the aurora. Next, our weather.gov map, and we've got some very cold temperatures there in the east central portion of the country, hard freeze warnings and frost advisories and freeze watches, etc. If your location is lit up on the map, head to weather.gov and click your location. And let's do some forecasts. So here's your temperature anomaly forecast in degrees Celsius based on a GFS 72-hour model. Eastern portion of the country, mostly anomalously cold. Western portion of the country, somewhat anomalously warm. Major snowmelt continues after a 7th consecutive winter of record snow in the northern hemisphere. Here's your pressure and precipitation forecast. We've got more severe weather here showing up in eastern Colorado, Kansas, Oklahoma, and northern Texas. Moving down to the southeast, actually, this time. Kind of moving right down the Rockies and then off to the east a bit. That's the same model, by the way, the GFS 72-hour pressure and precipitation. Next, our windy.com map, and we've just brought up a basic mean sea level pressure map here as it continues to be stormy in the northern Atlantic there. Strong low just hanging out in between Newfoundland and Azores. And check out the berserk lightning storm that happened in the Gulf. That's the past about 10 hours, and dag! That was some serious lightning in the Gulf. Let's see if we have any current strikes. We've got some strong lightning there in southern Mexico. Actually, right on the coast. Anyway, next time you hear lightning, perhaps check out lightningmaps.org. It's pretty sweet. Here is our U.S. Doppler radar map. We're going to focus on the lower 48 for the remainder of the video. There is vertical motion of the air column. Here is clouds and fog. And there is water vapor. Hopefully that clears things up. Some crazy rainfall recently happening in the Gulf. Here's your recap, U.S. Doppler radar. This is a value-added service, clouds and fog, even though it's dark over half the country. As we show you things you would not otherwise be able to see. And there is the water vapor map. Once again, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smasher Mash, and I'm not signing off yet because these videos were brought to you in part by our affiliate/sponsors. So first, thanks to Hemp Lucid. You can find a link below the video as well as on the homepage of the Hemp Lucid products. There are the most popular. Save some cash by entering the promo code SMASHOMASH on checkout. Enter the promo code SMASHOMASH on checkout for your mushroom gummies, your immune boosters, your CBD products, your body balms, etc. You can find links below the video as well as on the homepage at smashomash.com. And welcome to the Neo Renaissance. The official homepage was founded in 2019 in response to pathetic censorship on Facebook. A crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped the maximum security social media stockade of the internet underground, where we survive as producers of fortune. If you can find the content, and if you If you have a problem and no one else can help, maybe you can hire the Smash Team. No, you certainly can hire the Smash Team. There's a link right there on the homepage to the Smash Team. Thanks for tuning in. Congratulations once again on realizing the channel exists. We'll talk to you soon with more of the most detailed solar imagery and space weather you'll find in the known universe. And in the meantime, may that solar wind be at your back.